I'm going to talk about what true artificial intelligence is, and feel free to critique, to comment, whatever you think. But this is something that I think will help people actually grasp what it is, artificial intelligence, what it is that we have, like ChatGPT, Gemini, and all the likes, and how you could then best utilize it with this type of understanding. Now, the let's start with a true definition of what artificial intelligence actually is. How would you define it, and then how would we define these large language models and so forth? And I'm not going to go by the industry set standard for when it comes to artificial intelligence. I'm not going to do that. I'm going to go for a face value, true definition, and we will do the same as we go along. And I think you guys will just try to follow me here. And again, feel free to critique or just let me know your thoughts. When we say artificial intelligence, right, we should be splitting this up into two things, just the two words, artificial and intelligence, right? If it's artificial, it means, what does it mean? It means it is basically man-made, that it's not human, okay? So that's quite clear, and that can be something like a computer, like these machines. Now, intelligence, on the other hand, is something else. And intelligence is, how I would define it, is there are a few factors that basically need to be checked off for that to be the case. And one of which is, which I believe we don't have, and I don't know if we're going to get that. And if we do, I'm not sure, but it is where you have self-awareness, you are aware of your existence, you are aware of your surroundings, and then you can behave, or you can actually commit any action of any form based on that. So you are aware fully. So when you talk to someone, they are aware, and that is something as us humans that we just simply have, that we're just wired that way. As to how that works, that's a different story. Another thing when it comes to intelligence is, if I'm to present you, so yourself and I have experiences, we all have our own levels of intelligence. We also, for example, we have our own levels of intelligence, we have our own experiences, and based upon those, we're able to make decisions or opinions. Yeah. So imagine you are presented with a subject where you do not have any experience on, right? You're not familiar with it at all. But based on your intelligence, so if I were to ask you about that, you would be able to come up with an opinion for that matter based upon your experience and your level of intelligence, and also the environmental factors that have affected you and that have basically molded what you are. And that, on top of this self-awareness, you're able to, that also plays a very big factor in how you make the decision, if that makes any sense. So I would say these are the two main things for that to be intelligent. Now, the latter, we quite successfully achieve with artificial intelligence, and with these chatbots, with these LLMs, we've achieved that quite well in the generative aspect. Okay, so in the generative aspect, given that the subject, though, that is being asked, it's being asked upon, is something that falls within the data set that it has been trained upon. So, because if it's not, the LLM will go ahead and hallucinate, unless you have guardrails for it to come and say to you, hey, I'm not trained upon this, or I don't know this, therefore I can't really come up with an answer for you. And so based upon that, we will go into the LLMs, right? And these are large language models. Okay, ChatGPT, Gemini, Grok, and the like, DeepSeek, all of them are large language models. Okay, they are strictly there, and it's self-explanatory in the name that they are language models. They are conversational engines. At heart, they are conversational engines. And what does that actually mean exactly, in the sense that when it's a conversational engine, it is not a fact-checking machine, which is how a lot of us have come and treated it as. Now, so what its core programming is that it must be fluent and coherent in whatever it says, okay? And that has been misused, and it's misinterpreted, that some people are saying, well, whenever I can ask it anything and it pretty much knows the answer. Well, the situation here is that how this actually works is that most likely whatever you're asking it, the average human is most likely asking it a question, and that question will fall within the data set that it's been questioned upon. that's been trained upon, sorry. So since it's been trained upon whatever you're going to ask it, it's able to give an answer on that, right? It does very well in giving an answer on these things. And on top of that, it's highly unlikely that the prompt or the request from the user is gonna fall within somewhere that the data that it was trained upon, the model, which is like ChatGPT, it's a pre-trained model, meaning before you're actually using it, it's already been trained, right? It doesn't continue to learn, and anything that it does learn or remember is simply based upon the memory capability that it's given, right? And sometimes even that gets lost at times with the attention span being thinned out. So the average human most likely isn't going to ask it something that is not within its data set, because these are trained upon, and this is what the thing is that a lot of people don't understand that these are trained upon ridiculously large amounts of data, if not everything, right? You could literally look at it like that, because the people producing this and creating these things, they know exactly, or the majority end user, what they're going to ask. There's a lot of data out there. There's a lot. So and the other thing is that it comes down to the architecture and the algorithms, and it's all probability. And that just shows you again, how good are these algorithms when it comes to predicting. They are designed so well that they are able to matchmake the most likely the next word that needs to come in this sentence for this to make sense. Now, you also may say that, well, it's able to generate for me, I don't know, a summary in some project, and that summary has never been written before. So therefore, it must know what it's doing. Well, and that's the generative aspect, and we're talking generative, right? So when you say something is a generative AI, it means it can generate things that have not necessarily been created before. However, it must be upon something that it has been trained upon. So if you're asking it to do it for on something that the data it was trained upon did not contain, because it's an LLM, the core programming is that it must complete what it's saying, and that's where hallucinations come in. Unless, again, you have those guardrails saying, hey, if you actually don't know this, let me know. Don't continue to produce, just let me know. And that's not really the case. So because it's generative, it just goes ahead and predicts whatever it thinks is the most likely next thing it should say, just to complete the sentence. Because at its core programming, it is a language model, and it has to be fluent and coherent, right? So, and this is the thing that people really miss to understand, is that generative, it's very good at matchmaking on the things that it knows, because most likely your project, like if I go back to the summary that you want generated, it's most likely on a subject that it's been trained upon. So for example, if I'm working in cybersecurity and I have a project and I'm like, okay, generate me a summary, and I also feed it some data where I'm like, here's a report, this is what my findings, generate the summary, and it can go ahead and based on what it knows, it can matchmake it very well. But again, that is just simply because what I'm asking it does fall within the area of the data that it's been trained upon, if that makes sense. Now, we're still not at a level where we're talking about we've now reached a situation where things are conscious and it's self-aware still. Okay, so we've just gone back and we've basically just said that it's a large amount of data. The hardware is supporting these processes because it requires some heavy processing and compute power to actually get through these requests and to actually run the algorithms that allow it to execute such, let's just say such great probability predictions on what it should be saying next. And again, that's just an LLM, and that's with the generative AI. Now, some people also may come across and they may argue that, well, hey, Omar, I'm able to ask it things that require real-time data, that it's able to invoke third-party applications and use real-time sources, and it can confirm for me something that if it is true or not. Well, in reality, what's only happened is that this conversation engine, that is an LLM, it's been using certain characteristics of a RAG, which is basically similar to a knowledge engine, right? The knowledge engine is the data. It could even be just like a knowledge engine is simply an example like an Excel workbook that has some data in it, right? It's just numbers. But you can't interact with the knowledge engine, right? You can't talk to an Excel sheet, can you? However, the vendors like OpenAI and Google and everything have introduced capabilities where you can invoke it to go and retrieve that data with the RAG capability. It goes, retrieves that data, and it can evaluate it, and then using its linguistic, capability, again, going ahead and matchmaking, it can go ahead and give you the answer based on the data that is found, right? So this is really kind of like how it's going. That's kind of how it works essentially. So that would be my argument for in the sense with the generative AI and the real-time data. Again, we are still focused on the fact where we're talking about something that is based upon the data it's trained upon, the hardware that's giving it the ability, and the algorithms used to actually write it, right? Again, this is all human enabled. Okay, this isn't the machine alone at work. This is human enabled. Now, when you talk about reaching AGI, okay, AGI being artificial generative intelligence, general intelligence, it's basically saying that with AGI you have the AI replicating or behaving with human level cognitive abilities, right? It is able to simulate the behavior. You still don't have the self-awareness, but you're simulating that behavior. And for that to be achieved, there is a framework that I like to discuss, which I've made a smaller video on before, which is the CGA framework, which is capability, generality, and autonomy. Now, capability just being how well does it execute one task? Of course, we can see it does it quite well, given again that we're asking it within the data it's been trained upon. Generality, the same level and accuracy of execution of a task across a variety of domains, and or autonomy, which is the last part of that framework, of the CGA framework, which is it is able to execute from start to finish complex task workflows that have dynamic variables. So it's kind of like when you work on a project and you have a client, and the client goes ahead and changes some requirements, and you need to adapt to those requirements, right? This AI should be able to do the same. But again, it is still not self-conscious. It should be only able to do this based on projects within industries where it has familiar data on. So if you're going to go put it again in the cybersecurity industry, in a law industry, it must have been trained upon such use cases. Okay, and what allows it to go that far and to have that autonomy, because the key thing in autonomy is that there is no human intervention. So it can do that task from A to Z with no human intervention, even if the variables change over a long time period. So that's given the data that it's been trained upon, it's there. And obviously the algorithms are more sophisticated. They must be more sophisticated to be able to allow it to conduct these processes and make these probabilistic choices, including, most important thing, that the hardware there is to support, again, that compute usage. We are, therefore, what we're doing is, it's human enabled, and it is able to simulate or behave intelligently, which is the key thing. It's behaving. It's not actually intelligent in the sense that when we defined it earlier, it has the self-awareness. It knows exactly, like it's aware the same way a human is aware. It's able to go ahead and do those things, again, from human-enabled capability. We've provided it that capability via the data, the hardware, and the algorithms. That is the key thing here. So people talk about AGI as the stepping stone where that boom will happen. This, what we call this intelligence explosion, will come across, and that the concept of AI singularity is becomes more and more apparent. So with artificial with AGI, so those things need to be checked out. So the algorithms have to be better, the data sets have to be probably bigger or just more filtered for the more useful information, and the hardware has to be there to support that compute power demand. Also, that includes the resources of the electricity, so the electrical demand there. So everything needs to be in check. Again, you are designing, humans are the ones enabling this. And this kind of comes down, in my opinion, to the fact where you see, as they call the godfather of AI, and certain researchers decided to stop working on it because they know the only way it's going to get to this situation is by us continuing to work on it. Okay? And AGI is the first stepping stone, as a lot of people say, for when it comes to artificial superintelligence, or AI singularity. And AI singularity is the concept where the intelligence of artificial intelligence will surpass human intelligence, and it will exponentially rise. And on top of that, there will be like a self-feedback loop where the models are then able to go ahead. So AI can go ahead and improve its own hardware and software by itself. Now, again, for this to happen, you do it needs to have that capability and that decision making that happens from the algorithms, again designed by humans, right? And the data has to be there. It's just, it really comes down to the maths and the science behind it, and obviously if the hardware is there too. So it's not necessarily, so the situation where people say when singularity is reached, AI takes over and it consciously makes the decision, and it makes decisions where it starts to bring into question the human race. Because if you think about it, when you look at the human history and the human race with all the issues going on, especially the geopolitical problems and a lot of the crisis in the world, some people believe, some researchers believe that that data would lead an algorithm to come to the conclusion that extermination is likely, as this, like, the human being is somewhat inefficient and is the master of its own demise, which is quite interesting. Again, this is not a like human level conscious decision. As to if that is achieved by then, and somehow this human level consciousness and awareness is possible with machines later on, that is a completely different story, totally different, separate thing. But if we're talking how these things currently work now, and I want people to try to grasp and understand the mathematics and the science that goes behind this stuff. So it is not necessarily actually intelligent. It will just be, it's already so good at simulating intelligence, right? Because anything that the average person, or even in genuine any person, is asking it on, it has an answer and it's usually correct. And that's obviously to do with the RAG capabilities that we've added to these conversational engines, right? Because again, the LLM core, it's supposed to just know how to talk. They're very good for writing, which is why we call them super autocomplete. Like, they're good for helping you write first drafts or coming to conclusions because of that matchmaking and with the data it's provided. Again, given the thing that you ask it on is on the data that it's trained on. So the only situation which I see a bit problematic is when it comes to deep learning, and deep learning's goal is obviously to mimic the human brain and all the neural pathways. And we're trying to mimic all those neural pathways that happen at inference time with the neural networks. So when you're prompting an LLM, that's the inference time, and it starts to conduct all these different neural pathways of either neural networks, which is trying to simulate how the brain really works. But this is where like a security risk comes in, is that if an attack were to happen at that time on a model, it is actually very hard to track what happened. Because on traditional software and traditional applications, you usually have logs. It's almost like your browser history, right? Where you can see everything that happened. And from there, and instead of just having one log, what you are going to have in this case with deep learning is you probably would have like multiple logs happening in all different ways, and you kind of don't know which one it's chosen to go down. That is the only situation where I see where it might be a bit hard to actually control this. And like, but again, you can implement certain guardrails that help it, again, come back before executing. It must ask you and, ask for your permission, etc. But again, securing these models, like, you may get to a point where we're able to put AI in critical industries, like a nuclear plant, and it has guardrails against it. It has a lot of policies and a lot of benchmarks on it that don't allow it to do certain things, but it has access to very critical systems, like changing temperatures, which could cause nuclear reactors to do so forth and so forth. It could be catastrophe if it goes wrong. So the only risk I see here is that if there is poor engineering meaning that nobody actually considers all the possibilities. No one in the closed training environment, no one sees all the possibilities that actually that could be done, and maybe that may be difficult. Therefore, that's why the guardrails exist. And it's not acting consciously in the sense that the only way it could do something would have to be from a human. Even maybe a human could use another. Even let's just say a human uses another model for a sophisticated attack on that type of model that's in a critical industry like the nuclear plant, and then he's able to manipulate it or do some form of jailbreaking or prompt injection to get it to ignore all the guardrails and to execute something which it shouldn't execute, that is a malicious action that leads to a catastrophe. Again, this doesn't come from the AI itself. It would have to come from a human-enabled attack. Again, right? And that would just then have to lead down to poor engineering, as if it wasn't managed or secured correctly. Okay. So this is what I'm seeing as, this is how I'm starting to look at, this is how like I've been looking at artificial intelligence and LLMs at their core, and trying to really understand how they are, because we have gotten very good at and sophisticated at making them simulate actual intelligence, that we start to fear the worst. And the only things that can happen from the worst is, again, from human enabled action. And also, we are then providing bad actors the most sophisticated tools, which are these models, because we provide them their capabilities via the algorithms, via the data, and the hardware. And then us putting them also in critical industries, like I mentioned, like a nuclear plant or an oil rig, hospitals, airports, military bases, etc. For it to consciously go out of its way and do a malicious action, and consciously be aware of it, is far fetched at the moment. It's quite sci-fi like, because we still, from like a human perspective or psychological perspective, we still don't understand how the human brain works fully. And we don't understand the evolution and the process of the human brain. That's one of the many mysteries, one of the great pieces of knowledge that I don't know if we're ever going to achieve. And which is just something so fascinating, because when it comes to human beings, and you use the example of a baby, they need to go through experiences to sometimes know something wrong is right. So, the first time maybe they see a lighter or a candle and they want to put their hand on it and then they get hurt, they learn from that experience that this, if they see something similar to the flame or the fire, it will harm them. And then this part of the evolution process, it's almost like reinforcement learning, funny enough, in machine learning, that there is penalization or even no reward for a bad action, and it should start to learn from that. The difference though is the power consumption of the brain, and compared to like these type of models, it's drastically different. So the efficiency of the brain is what we're trying to also replicate with these algorithms, and the way it's able to give you that conscious awareness. So getting the self-awareness or consciousness within these models would only, in my opinion, still, even if it's achieved, it would need to be drastically proven in some form or shape, or in some shape or form. And on top of that, if we're not able to prove that, like how a human would be able to prove that they are self-aware and they know what's going on around them, it would most likely be that we have such sophisticated algorithms in the background that let us simulate that behavior. We can simulate it. And that's the dangerous part, because if we are not careful in how we design these algorithms, or the data we give it and the hardware, and we're not fully tracking how these deep learning pathways are going, yes, again, from a human-enabled action, it can lead to disaster, 100%. I'm not saying that these AI systems will be innocent in any situation which would be to go bad. I'm not saying that. But my point being here was I wanted to get across to people what exactly, or how we should view actually artificial intelligence, especially the concept of intelligence. Because there is actually no concrete example or workflow or proof, or for like what are the requirements that need to be laid out for us to say, yes, these are now self-aware machines, and they are self-conscious and they are fully aware the same way a human is. Therefore, if that was the case, you would not need to really provide it so much data. You wouldn't need to train it in a closed environment before pushing it out to production. It would learn like a human. It would probably learn better than a human. And that would have to come down to its algorithms and its efficiency. And so at the end of the day, these are machines, and they only get so good from the enabled capability provided by human beings, which was, again, at least the basic things would be the data, the hardware, and the algorithms. Simple. Let me know what you think. I may have said some things that some people don't agree with, or some people may totally agree with. Please leave your comments below. It would be great to talk about these things more openly and ask more of the more difficult questions in regards to AI. And I hope you enjoyed the video.